at PAG. I'm the staff lead on and chair on the air quality subcommittee, and then the lead for our environmental planning advisory committee. The invitation was extended today to our EPAC members to either watch on the live YouTube stream or join us on Zoom to participate in the discussion. Looks like we're approaching quorum. However, there are no action items today. This is an informational item meeting, so we can proceed in that capacity. So I'll go ahead and do introductions. I'll call folks off as I see on the screen here, and then if you can just state your name and your affiliation. Josue.
Present.
Charles Stack.
Yeah, thank you, Dustin. Yeah, Charles Stack. I'm the citizen representative for Town of Oro Valley.
Kristen.
Hi, I'm a alternate for Natalie, and I'm the air program manager for PDEQ.
Great. Hannah.
Hey, good morning, everyone. I'm Hannah Oden, planning manager at PAG.
Taiwo.
Hi, everyone. I'm Taiwo Ajayi, and a PhD student in the Department of Hydrology at University of Arizona, and I work under the supervision of Amin Solution, who's also here.
Great, thanks. Melanie.
Good morning, Melanie Alvarez, and I'm a planning coordinator with PAG.
Armin.
Hi, Armin Sarushian, professor at the U of A, Taiwo's advisor in chemical and environmental engineering and also atmospheric sciences. Thank you.
Nalo.
Morning, everybody. Thank you, Dustin. My name is Nalo. I'm with the Town of Sarita Public Works. Thank you.
Jeanette.
Morning, everyone. This is Jeanette Deere, and I'm the Transportation Planning Director at PAG.
Natalie.
Good morning. I'm Natalie Shep. I'm the Climate and Community Engagement Manager with Pima County Department of Environmental Quality.
Abigail.
Good morning, everybody. I'm Abigail Okrent. I am the rules writer at Pima County Department of Environmental Quality, and I'm also the chair of the main EPAC.
Jessica.
Hi, I'm Jessica. I'm with ADEQ.
Karen.
Hi, I'm with Pima County Environmental Quality, Outreach and Education.
Allison.
Good morning, everyone. My name is Allison Price, and I also am with ADEQ, working in air quality planning.
Lydia.
Hi, everyone. Lydia Barker. I'm a planner with the City of Tucson Department of Transportation and Mobility.
And on the attendees list, I see Sky.
Hello, I'm Sky. I'm Community Engagement Coordinator with PDQ.
David.
Hi, good morning. David McAllister Romo, Green Valley Council.
And Mike.
Mike Draper, Monitoring Manager, Pima County DEQ.
Fatima.
Kanis Fatima, and I'm working with Natalie in the Department of Environmental Quality.
And last, I see Ave.
Hi, good morning. Ave Arellano, professor at U of A, hydrology, atmospheric science, and as well as chemical and environmental engineering.
All right, great. Did I miss anybody? All right, looks like that covered everybody. Move on to agenda item 2, the in-kind form. So I'll read this off. PAG's regional planning efforts are enhanced by recording time donated by attendees, volunteers, and participants. PAG collects data on the time dedicated to meetings and activities to apply for use as matching funds for grants and federal dollars. If you are paid with federal dollars, please let us know. Time spent in preparation for this meeting will be estimated by PAG staff who are knowledgeable of the agenda and meeting materials. At the conclusion of this meeting, the assessment report will automatically calculate your time spent in this meeting. Time spent working on PAG RTA initiatives, programs, and special projects may also be eligible for consideration for matching funds. So if you are eligible for that, please do let us know. All right, we'll proceed to agenda item 3, which is ozone research update. So representatives from the University of Arizona will present research being conducted on ozone trends in our region, updates on the ground level ozone research project, and variations of ozone precursors from remote sensing data sets. So we have 3 speakers. I can start off with introductions. Taiwo Ajayi received a Bachelor of Engineering in Agricultural Engineering from the Federal University of Technology in Akure, Nigeria. He is a graduate student with research interests in aerosols, cloud and radiative interaction, climate forecast and weather parameterization, development research, and drought forecasting. Armin Sarushian received a BS in Chemical Engineering from the University of Arizona and a PhD in Chemical Engineering from the Cal Institute of Technology. He completed a postdoc with the Cooperative Institute for Research in the Atmosphere, which involved research with Colorado State University and the National Oceanic and Atmospheric Administration. He has been a professor in the Department of Chemical Engineering, Environmental Engineering at the University of Arizona since 2009, with courtesy appointments in Hydrology and Atmospheric Sciences, the College of Optical Sciences, and the College of Public Health. Armin is both a University Distinguished Scholar and a Da Vinci Fellow. And last, Ave Arellano is an associate professor at the University of Arizona Department of Hydrology and Atmospheric Sciences. He is also a joint faculty member of Chemical and Environmental Engineering, as well as graduate interdisciplinary programs on remote sensing and spatial analysis and on applied mathematics. As a professor on data assimilation and atmospheric chemistry, his research is directed towards improving our capability to assess, monitor, and predict the changes in the state of our Earth system by exploiting constraints from observational to ground-based to satellite remote sensing and modeling to local to global scale, along with correlative ancillary data sets such as socioeconomic indicators. We'll start off with Taiwo.
Thank you once again, Dustin. My name is Taiwo Ajayi, just like I said earlier, and I'm a 4th-year PhD candidate in the Department of Hydrology and Atmospheric Science. I work under Armin Sarushian, who is also here, and today we're going to be presenting on one of the projects we've worked on Tucson, which is the long-term examination of surface ozone concentration in Tucson, Arizona. Can everybody hear me clearly?
Yeah.
So just to reiterate that ground level ozone has implications for human health, for climates, for policies, and also for air quality and the environment. But one thing we need to know is that ground level ozone is formed through the process of the photolyzation of nitrogen oxides and the oxidation of volatile organic compounds in the presence of sunlight. This was formed to ground level ozone and is dangerous to human health, just like I said earlier. And ground level ozone has been studied in Arizona. Ground level ozone has been studied in Arizona extensively, and I think last year, in our group, Professor Dr. Armin Sarushian wrote a review paper that looked at some of the studies that have been done over Arizona, and over 65 publications on ozone research, and with the first one in 1996, with one major field campaign in 2001 by ADEQ and Department of Energy, and that was focused basically on Phoenix sunrise experiment. And one thing we kind of realized with some of the studies that have been done over Arizona is that most times focused on Phoenix, maybe due to being in a non-attainment zone, but limited work has been done over Tucson and other cities. And this work has spun our attention to see who has done something regarding to like Tucson ozone studies. And kind of see that it was only DM kind of look at the weekday effect of ozone, and that was in the late 90s, between 1995 and 1998, which was our motivation to expand on a study by providing like an updated multi-season assessment of ozone trends and chemical regimes in Tucson. So for this study, we have 8 locations across Tucson, and we have like which are divided into 3 subgroups, which is the Northwest, which you have the Coachline and Tangerine. Then you have the urban core, which is in purple, which is Children's Park, Rose Elementary, and Craycroft. And we have the South and Southeast, which is Sahara National Park and Fairgrounds. And on the same map, you have like an ozone 24-hour ozone loss pollution rows that shows you the transport of ozone over Tucson. So for this study, we made use of Environmental Protection Agency Air Quality System dataset, which is the maximum daily 8-hour average ozone concentration. And also for metrology, we made use of EPA dataset for temperature, relative humidity, wind. But when it comes to precipitation, we use the Persian dataset, which is precipitation estimation from remote sensing information through artificial neural network. It's a dataset housed by the University of Irvine. And also for our planetary band layer heights, which is to understand entrainment and also of ozone, we use MERA2. And for land cover, land use change, we use and for vegetation, we use multi-resolution land cover from the National Land Cover Database. And also we use the Normalized Difference Vegetation Index from MODIS to help us understand how as the vegetation over Tucson change over time. So, and for this study, we use a data set from 2001 to 2022, and we kind of divide this data set into 4 bin periods to help us understand the trends from 2001 to 2009, from 2010 to 2019, 2020, and 2021 to 2022. I think we isolated 2020 due to the COVID-19 pandemic. And during that period, people are more indoors, and we try to understand it in its own context. Also, we look at the seasonal medians, we look at the ozone design values, which I know is more relevant for policy. And it's ozone design values, a 3-year average of the 4th annual highest maximum daily 8-hour average ozone concentration. What I mean is, in each year, within a 3-year window, you take the 4th highest of each individual year, and you take the mean, which gives you a value which is more relevant for looking at non-attainment and is majorly used by EPAs for policy. We also look at the weekday difference. This is when we have the average of weekend, which is Saturday, Sunday, minus the average of weekday, which is Monday through to Friday. So we take the difference. If you have a positive value, it's more weekend. If you have a negative value, it's more weekday effect. Then we look at the chemistry, and for this chemistry, we made use of ozone monitoring instrument and tropospheric monitoring instrument, which has nitrogen oxides and volatile organic compound. And just like I said earlier, keep in mind that for ozone to form, you need VOC and NOx. So which is why we need to understand this chemistry. And also we look at the deseasonalized correlation between ozone, like what is the relationship between ozone, vegetation, and emissions and metrology. Then also to understand, because Tucson metrology kind of behaves different, Arizona metrology behaves kind of different. Look at the impact of metrology on ozone by isolating its own, by isolating its effects. Because during the monsoon, you have the dry summer and the monsoon summer. And that's because summer is separated into 2 aspects. Because the dry summer is more like clear sky and it's more dry, and you have high temperature, low humidity. But during the monsoon, it's kind of different. So we also look at that. So looking into the ozone design values, one thing I want to put our attention to is, if you look at the ozone pollution rows, you can see that for Fairgrounds and Sahara National Park, you can see the ozone transport is majorly from the urban core center, which is more like downwind of this urban core. And one thing you can see is from 2001 to 2008, you can see that ozone is more steady across board. But you can see that the concentration of ozone at Sahara National Park and Fairgrounds were kind of elevated, as well as in the urban core. But from 2009 to 2016, you can see it's kind of different because it declined, and you can kind of give that to the regulatory measures that has been put in place. But from 2017 to 2022, you can see that it started going back up and going back to the normal, start increasing. So we also look at the seasonal trends of ozone to understand how it evolves seasonally. And one thing I said earlier is we have 3 subgroups. So each stations were divided into these 3 subgroups. And one thing is, and also to reiterate, the fall and winter season were combined together because they are kind of have the same seasonal pattern. So to also help us understand this better. So one thing we can say is that for Southeast, South, and South side, you can see it's recorded the highest ozone concentration, especially in fall and winter season, which is like 2 to 4 ppb higher, parts per billion higher than the other 2 subgroups, which is the urban core and the northwest side. And another thing I also want to point out is if you look at the other seasons, ozone has no significant long-term trend. You can see it's more or less relatively stable. And it's not as if there is no trend, but it's kind of insignificant. Except that you can see that in the urban core, you have like an increasing significant trend, which is during the fall-winter season. Also, we look at the day of the week pattern to understand what is the weekly cycle of ozone. And to retrieve, just like I said earlier, 2001, we have 4 bin periods: 2001 to 2009, 2010 to 2019, 2020, which is the COVID-19 pandemic year, and 2021 to 2022. And one thing we can observe is from 2001 to like 2019, the 2 bin periods, you have weekend maxima and weekday minima. And one thing you can likely attribute this to is due to like during the weekdays, you have NOx saturation, because when you have more abundance of NOx, it helps to limit ozone formation. But during weekends, it's kind of different because people are more indoor. So the availability of NOx during that period helps to facilitate the increase of ozone concentration. That's why you have more weekend maxima than weekday. But in 2020, it was different, because in 2020, you can see it's more weekday maxima. Just like I said earlier, because people are more indoor, the availability of NOx at that point is abundant enough to make a weekday peak in ozone concentration. But if you look at dry and monsoon summer, you can see it consistently showed a weekday maxima. But one thing that drew our attention was the dry summer of 2020, where you can see like a weekly ramp up in ozone concentration. And this kind of agree with what we observe in a surface site of from NO2, which is Children's Park and Craycroft, where you can see like also a weekly ramp up in nitrogen dioxide. So to understand ozone formation, ground level ozone, you need to understand the chemistry. And just like to retrace earlier, you need volatile organic compounds and NOx. So when you have volatile organic compounds and NOx, there's something called the formaldehyde to NOx ratio, which helps you to understand what regime ozone is being formed. So we looked at this for a NOx limited regime. For ozone to form in a NOx limited regime, you need to increase NOx, and it's insensitive to VOCs. But in a volatile organic compound limited regime, for ozone to form, you need to reduce NOx, and it's sensitive, and you need to reduce NOx. So in a in a VOC limited regime, for ozone to form, you need to increase volatile organic compound. That's what I mean, sorry. And one thing I just want to say is if you look at nitrogen oxide, you can see that there is a decline across the bin periods from 2005 to like 2022 and 2020. You can see that there's a steady decline in NOx, which can be attributed to regulatory emission changes. But you can see that in 2021 to 2022, you can see that it started going back up a little bit. But for volatile organic compounds, more or less relatively stable across season. You can see it's more like sometimes you see like it's not significantly relevant. But 2020, you can see it's kind of a little bit different, because in this period, it's more, this peak is attributed to like fire-related activities. but in 2021, 2022, it kind of reverted back. So just like I said earlier, to understand ozone chemistry, you need to understand the relationship between formaldehyde and NOx, which helps to tell you which regime ozone is in. And sorry, you need to understand which regime ozone is in. And you can see that in 2005, 2009, you can see that you have a negative anomaly of ozone, of FNR ratio. But from 2010 to like 2020, you can see that there's a positive anomaly of formaldehyde to NOx ratio. But post-COVID, you can see it's reverted back to like a negative anomaly. So this is saying that in this 2005, 2009 being period, when you have a negative anomaly, that means ozone is more 2005, 2009, ozone is more sorry, I'm trying to from 2005 to 2009, ozone is negative anomaly. This negative anomaly kind of shows that ozone is
Taiwo, I think you're just trying to say that the chemical regime might be changing in the atmosphere.
exactly. Sorry, I just had like
It's okay. Yeah.
So it's changing in the atmosphere. Thank you for that. Also, we kind of look at emissions from National Emission Inventory, which is an EPA data set. This kind of shows like a bottom-up total estimated emissions from sources like points, which involves industry, non-road, on-road, fire, and biogenic. I can see from CO sectoral emissions and NOx emissions, you can see there's a decline in these emissions, and we can attribute this, just like I said earlier, to regulatory controls. But it's kind of different for volatile organic compounds, because for biogenic, you can see there's a sudden drop from 2014 to 2017. And one thing I just want to say is biogenic volatile organic compound is not reported, it's calculated or it's estimated from models. So that's why you might see like a sudden or sharp decline from this. Also, we look at the land cover, land use, to understand how has Tucson evolved over time, because population of Tucson from the late 90s to like 2022 has increased with over 30%. And you can see that Tucson urban core has evolved and developed from like, it's been converted from like a shrubland to like developed areas. And this can help to highlight that the increased ozone concentration we're observing at the southeast side can reflect like downwind transport and increased precursor emissions from the expanding urban zones. Also, to look at the deseasonalized interrelationship, we use something called the Schlemmer correlation to help us understand what is the relationship between ozone and emissions, meteorology, and vegetation. One thing we observed was there was a negative correlation between normalized difference vegetation and ozone. This suggests that when you have high vegetation, it corresponds to lower ozone. So this finding kind of helps support the hypothesis that urban growth and related vegetation might affect ozone variability. Also, just like I said earlier, to understand the impact of meteorology, we use something called the generalized additive model, which is a kind of a non-linear model. This helps to isolate impact of meteorology on ozone. So what this model does is, to get the observed, you kind of fit in a bunch of meteorological parameters and emissions into this model and get like what will be observed trend across the time period you're looking at. So for this, we have like an observed trend. Then after that, you kind of keep, okay, what if meteorology is not changing? What if you keep it fixed? What will be the impact of meteorology on ozone just by varying only emissions? That means across the time period we use from maybe 2010 to 2022, meteorology is kept fixed, relative humidity is kept constant, precipitation is kept constant, and every other meteorological parameters are kept constant. So what will be the impact? And one thing we realized was that 79% of the small increase in ozone concentration in Tucson is meteorologically driven. highlighting that there's a relationship between emissions and metrology. Just to conclude, what we can conclude from this is that spring and summer has the highest ozone concentration, which is driven by photochemistry. Just like I said earlier, to understand ozone, you need to understand the volatile organic compounds and the NOx emissions at play. And also, you can see that metrology metrology estimated to kind of explain the considerable ozone variability. But one thing we can take away from this is that you cannot understand ozone variability without considering urban growth, land cover, metrology, underscoring the needs for air quality with a land use and population data set. But we have a limitation in this study. Just like I pointed out earlier, most of the work that has been done over Arizona has been Phoenix, but also there is lack of widespread volatile organic compound measurement, surface measurement, as well as speciated VOC measurement, which is lacking and would have helped in allocating, what point source, what kind of VOC is being emitted. And because different VOCs have different reaction rate and how it reacts with ozone. And for future work, we kind of proceed that there should be an expand surface nitrogen oxide and volatile organic compound monitoring sites to help to better classify chemical regimes and guide adaptive air quality management. Thank you.
Great, thanks, Taiwo, so much for that historic review of ozone. We'll continue on with Armin, and then at the end of the ozone presentations, we can take some questions. Go ahead, Armin.
Thank you. First, I wanted to thank you, Dustin, for including us, inviting us to this session. It's great for us to kind of see the implications and applications of our basic science work connecting to the policy side. And it's really helpful for our students like Taiwo to have this opportunity to present to you. So again, thank you very much for having us. I'll try to make up for some time, and I apologize in advance. At 9:55, I'll abruptly leave to go teach a class at 10. But I wanted to give a little background as to why we're kind of here. About approximately 3.5 years ago, we had an opportunity given to us by the Arizona Board of Regents. They provided some funding for a few topical areas of emerging concern, one of which was valley fever, another was PFAS. One of them, though, was ground level ozone, and that's where Ave and I got involved with some colleagues at ASU, who you see on this slide. So we got some funding for 3 years to do modeling, look at data, and that's kind of come to a close. And now, with the help of ASU and a lot of different companies around Phoenix, we have some renewed funding, which kind of helps support this effort that you see on this slide called the Ground Level Ozone Research Campaign, which we refer to as GLORE. So GLORE basically just wrapped up in terms of the measurement period, and now we have 2.5 years of funding to look at the data. And we have a little article in the bottom that you can see here, published in the EM magazine, which is more for policymakers. Maybe some of you are subscribed to that, which you can go look at. So we'll go to the next slide. I'll give you a little bit of background about, oh, am I the one controlling it? I see this. Okay, let me back up. Okay, so the motivation for a lot of GLORE and how it came to be and why we got all this funding from Maricopa County is there's all this concern over the ozone design value in recent years not going down as would be expected based on the decreases of its precursors, which are anthropogenic VOCs and NOx, which are represented by the light and dark gray bars here on this chart. But the ozone design values in the colored markers have been pretty stable, if not sort of increasing a bit for many of the Intermountain West metropolitan areas. So we show Denver, the Front Range of Colorado, Las Vegas, and Maricopa County here. So this is, of course, a concern, and so we want to look more into it. And so the universities are getting more aggressively involved with measurements and data analysis. So a lot of over a year went into the planning of this GLORE campaign about how we can use some resources given to us to do a major campaign to get more detailed data, especially for speciated VOCs, which are lacking. And we wanted to get vertical information, which is hard to do at places like Children's Park or 22nd and Craycroft. There's a lot going on in the vertical direction that matters. So we explored doing an airborne campaign, but we realized that's not probably the best thing to do immediately, and we decided to stick to a ground-based campaign, which I'll summarize in the coming slides. But this is a little bit of regional context. There's been a plethora of major campaigns around Arizona in like the Las Vegas area, the Denver metro area, Salt Lake area, California. And this is just a map showing them with all these different icons of the different campaigns and logos and so forth. So Arizona, we were hoping can catch up and become, get some resources to do similarly large efforts to get more information to help us out. On top of that, we have advances in remote sensing. So we have the Tempo remote sensing capability now, and we have a Pandora instrument, which Ave will talk about after me, that we have right here on campus on top of the Goat Simpson building, which is providing us really nice data as well. So we're trying to make, get a lot of rich data like our Intermountain West neighbors. So here's the GLOR setup. This is what we decided to do. With the resources, instead of doing an airborne campaign, we said, let's instrument 7 different sites around Maricopa County with 2 upwind, which are shown on this map here, Alamo Lake and Buckeye. We wanted a few urban core sites and 3 downwind sites because the prevalent flow is from sort of west to east in this valley area. And we instrumented each site with capabilities from Sonoma Tech. We contracted with them with auto GCs and various other instruments to measure all kinds of VOCs, NOx, NOI, formaldehyde, and ozone. On top of that, we got 2 ozone LiDAR instruments to help us with information in the vertical direction to make up for the absence of an aircraft. So we put the 2 ozone LiDARs at Buckeye and Durango. And it turned out those are really important capabilities that we're going to try to continue having in Maricopa County. So although we wanted to start in April, as with most field campaigns, there are delays, and really the measurement started right around June 1st. Okay, and so throughout the whole GLOR period from June 1st to the end of October, we were daily watching all these instruments, keeping track of the data capture rates as shown by these busy plots here. It's not meant for you to read everything on here, but it's just meant to show that a lot of diligence was put into tracking all the different VOCs, all the NO species we were monitoring to make sure the instruments were working, which thankfully they mostly were during GLOR. So that was for the VOCs. This is the NOx data capture rate. Red means good. And here's formaldehyde, and yellowish is also very good here. So formaldehyde was a great success for us to get good measurements of that on hourly time resolution, if not better. So during the GLOR period in Maricopa County, we kept track of exceedance events. And so that's kind of captured here on the y-axis by the dates. And on the x-axis are all the different sites across Maricopa County, including more than we had just in the GLOR with our own instruments. So there were quite a few exceedances up till about June 18th, and then there was this hiatus for a long time, which was very frustrating for us because we had all these instruments and we wanted to get great data during exceedance events, but it was kind of an anomalous ozone season in Maricopa County without many exceedances. But there was this period between August 20 and 28 when there was a little bit of a comeback with higher ozone levels. So we had some really good data during that 8-day period or so. Another important aspect of GLOR is to kind of look at common exceedance events across the Intermountain West, because we hypothesize that there are some regional factors that are leading to exceedances in these different spots. And maybe it's not all primarily due to local influences. So June 18th, this past summer, was a classic case of there being a lot of exceedances across these different areas shown on this map. And so I'll get back to that June 18th case in a couple of slides. Another aspect of GLOR is monitoring wildfire. And so for this, we're using different tools, but primarily this NOAA hazard mapping system, which relies on remote sensing data, where analysts take them and produce these sort of polygons that you can see on this map to determine if there's light, medium, or heavy smoke. So we were religiously monitoring the wildfire activity this past summer with these types of maps. So that ozone LiDAR that I mentioned that we had at 2 sites, it was really important, again, to have them to see what's going on in the vertical direction. And so this is a period, including June 18th, where we had exceedances across the 4 states that are kind of in the desert Southwest. And you can see there's very high ozone up here, upwards of like 9-10 kilometers in the stratosphere. And you can see that the LiDAR instrument kind of tracked the downward descent of this ozone-rich sort of plume of air. And this is referred to as a stratospheric intrusion, which led to the exceedances, or at least contributed to the exceedances across the desert Southwest, not just in Maricopa County. And so this is the beauty of having something like an aircraft or these ozone LiDARs to be able to detect these events, because if you just relied on those surface instruments, you wouldn't really know that this was contributing to why there was an exceedance in a specific area. And then with Ave's capabilities and his team, there was a lot of modeling going on with this WRF-Chem model. And so with that, we were able to reproduce kind of that stratospheric intrusion event. So that's another important aspect of GLORE, doing some model evaluation to see how well we can simulate things that we're seeing from our actual field data. So that's kind of like a sneak peek of things that we sort of did in GLORE, but really the hard work begins now with the data mining and analysis to kind of figure out what are all the different factors and the relative weights of these factors in leading to these ozone exceedances. And again, GLORE occurred during an anomalous summer where it was actually a little bit cleaner than expected. So we got to keep that in mind too. So this slide acknowledges all the folks that helped raise all the funds we needed to do the GLORE campaign and the ensuing data analysis. So with that, I will stop. And again, thank you for your time, and I will let Ave continue.
Thank you, Armin. You go ahead, Ave.
I think I need a slide. All right. No. Okay. Again, Dustin, thank you for having us. This is a really good opportunity, as Armin mentioned, to actually share our results. This work is mostly from my students, Meg, Chayan, Amin, and then my former postdoc who's now at Sonoma Tech. What we are really interested in this work is to kind of build on what Taiwo look at in terms of the POC NOx limited regimes for Pima County. And so we were lucky to have NASA Excite, Armin's leading it, a program wherein we have installed Pandora. It's a spectrometer looking up. It's a ground-based remote sensing looking up, but it gives you the main ingredients of ozone formation, which is VOC and NOx. So we have NO2 measurements over that Pandora, and then we also have formaldehyde. Unfortunately, we don't really have the primary VOCs. We only have kind of the most oxidized state of carbon in terms of VOC, which is formaldehyde. And so what we wanted to do was to look at the urinal variation and seasonal variation. Taiwo already mentioned the seasonal variation. So we were going to be really focusing on understanding these precursors, formaldehyde and NOx, in the formation of ozone. What I'm showing you here is just a diagram of the chemical regimes, and Taiwo explained this very well, that when you have too much NOx in the system, or in Pima County, then you end up with a VOC limited regime because you have too much NOx. So you're in the right-hand side of this graph. When you have a lot of VOCs, but a little bit of NOx, mostly rural areas, then you'll be in the NOx limited regime. And from what we had before, our findings would say that the Tucson metropolitan is in the transition regime. And that means that the peak of the ozone production is actually in the transition regime. Note that that's the peak in the curve, and so if you go reduce NOx, then you decrease ozone. If you reduce VOCs, you also decrease ozone production. However, if you are in a near VOC regime, if you reduce NOx, then you end up with ozone increase, which actually was seen in Taiwo's paper, wherein the weekend effect, decreasing in NOx during the weekend, increases ozone. And so the other thing that we wanted to understand is the connection between this Pandora instrument, which is unprecedented in terms of formaldehyde data sets, sub-hourly data sets of formaldehyde, which we could not really find even in our PAMS network. So we wanted to connect that to ozone, but also connect this with what the community is very, very much excited about, which is tempo. It's kind of a weather-like ozone NO2 formaldehyde observation that we can actually look at. And so we are very much interested in looking at those satellites and then relating it to surface measurements of ozone. So what we did was to pick nearby sites in the UAE campus, which is Craycroft and Children's Park. And we were going to be looking at just the seasonal and diurnal variation, daytime variation of ozone in relation to the precursors that we see at Pandora. So I don't want to go over this, but the idea is that yes, there is photochemistry in the summer and during the day, especially at noontime. And there's a mixture again of these three ingredients: light, VOC, and NOx. Depending on the mixture, you end up with either increase in ozone or decrease in ozone. So first off, we were comparing this seasonality of Pandora, which is shown here in light blue, which is not of the same unit as this ground level measurements that we have at Craycroft or Children's Park. But you see the seasonality is actually captured by Pandora relatively. But then what we also see is the rapid increase or steep increase in formaldehyde during June and July. We attribute this to the fact that most of June, very dry summer, is more temperature response of formaldehyde. But then once monsoon kicks in, then you end up with more of a vegetation response. And so the land cover and vegetation grow, and hence you produce more VOCs, biogenic VOCs. This is a data sets from 2024 to currently 2025, also in time within the tempo availability of the data. So when we look at what's more interesting is actually the diurnal cycle, which we could not really see in the past because we don't have measurements of formaldehyde. We have very limited measurements of formaldehyde. What we see is that ozone in both Craycroft and Children's Park actually peaks before noon and then just lingers on there until 5 o'clock, and it drops off during the sunset again because of these ingredients. But it lingers on around 5 p.m. Whereas the NOx, obviously, you expect rush hours to have higher NOx and lower boundary layer, so you end up with higher NO2. What we didn't really, and we're still puzzled with this, is the flatness of this daytime variation in formaldehyde. We expect the formaldehyde increases in the morning, increases in the emissions of VOCs in the early morning, and the formaldehyde photolyzes and loses and removes in the atmosphere. So you end up with peaking around 12 o'clock as well, and drops off, as you can also see from the seasonality of formaldehyde. We see similarity as well in the GLORE campaign, but there is some amplitude in the seasonal diurnal variations in Durango, for example, but we don't see it here. We attribute this to the column measurement of Pandora, the column nature of it, but we are still finding out the reason behind this formaldehyde non-existence in terms of the urinal variations. So I said we were excited about tempo, and so we want to compare Pandora variations with tempo. This is NO2 and formaldehyde, and we are grouping it into month and 9 a.m., 11, 1, and 3. So the columns corresponds to the variations in the daytime. The rows corresponds to the seasonal variation of the daytime. So we expect obviously NOx to be very localized, and you see actually the land cover of Tucson, Metro Tucson, and then you end up with a kind of increasing also in the northwest. So this is expected. We expect the spatial coverage of NO2. There's some hotspots that we still don't understand if it's an artifact or a rogue power plant or something. What we didn't really expect is the noisiness of the data for formaldehyde from tempo. We do see this response of the vegetation and temperature, and especially in the areas where you expect land cover, trees and terpenes, obviously. But there are some, again, hotspots that we're still working on. Formaldehyde looks like from Pandora sites is more or less similar in terms of variation, like tempo. So we want to understand that more. And so we did some modeling work, and I'm sorry for this very busy slides, but the left-hand side here corresponds to what Tayo mentioned, the chemical regime. So we have two indicators here, H2O2 production ratio with HNO3, and then what was typically done in the community, which is the ratio of formaldehyde and NO2, right? The higher the formaldehyde, the higher the VOCs, the higher this ratio, and you end up with more of a NOx limited regime. The other way around, NOx limited, NOx saturated regime or NOx limited regime, we have VOC. And so what we found was that Tucson is, if you take up all of the data of Children's Park from the model, and we kind of calculated that ratio, the probability of that ratio, the mean of that is about 0.2 in terms of the ratio of H2O2 and HNO3. But what is fascinating is if we just classify or group the high ozone values during that time, you end up with the same chemical regime. And so what we say, what we find is that Tucson is actually in the transition regime, regardless of its high ozone events or for the rest of the time. Phoenix, on the other hand, is the opposite. We are in kind of a near VOC regime in Phoenix for all the data during this 11 to 3 time period. But then if the high ozone levels in Phoenix is actually associated with the transition regime. So there's some differences in Tucson and Phoenix. A big difference, in fact, is what we calculated in terms of the production and loss of this ozone. Right? So there's a lot of production in Tucson than in Phoenix, a factor of 2 production, but there's also a lot of losses in Phoenix, in Tucson than in Phoenix. So we were trying to understand that even though there's really large production and loss rates of ozone formation here in Tucson, we still don't see a lot of exceedances compared to Phoenix. So we're trying to figure out this impact of that exceedance, the higher part of ozone in Phoenix, and why is it that it's actually having that, even though the production and loss is lower. Lastly, I would like to point out that we had published a paper last year or this year looking at background ozone. We can argue what the meaning of background is. We think about it as other than what we produce here in Arizona. So something ozone from California and ozone from precursors and producing ozone over from Asia going to our region. And so what we found is that there's a lot of background ozone And it's consistent with what we saw or what people have suggested, which is about 60 to 65 ppb of ozone is background. It's not the enhancement due to this NOx or VOC increase. And so just because this is still a very, very new topic and there's a lot of uncertainty with regards to this background ozone, but I'm just suggesting here that there is this research that's quantifying this background ozone, and turns out most of them are suggesting that it's greater than 50 ppb, and if 70 ppbs are exceedance standards for exceedance, then we don't have a lot of wiggle room for reduction. That's all I have. Thank you.
Great. Thanks so much, Dr. Ariano. Now, Dr. Sershin, you have to get going to class soon. So we'll open up for some questions and folks can contact you individually also with questions. This is a big, important topic. Needless to say, ozone is a complicated pollutant for the NACs. EPA sets the health standards. We have the regulatory requirements, and this is helping, I think, your research understand, in the Intermountain West with the different influences of wildfire and atmospheric intrusion and background and the vertical profiles. So let's go ahead. Looks like Natalie, go ahead.
By the way, one thing before I go,
Sure.
I just wanted to mention another good outcome of GLORE. And I think I saw Mike Draper's name. We've been in touch with him. We're getting one of the shelters donated to us from the GLORE campaign. So the shelter with instruments at Alamo Lake, I forget which day, Mike. It's coming up in 1 or 2 days now. It's coming on a big truck to us. So it's a new thing we're getting. So it was a nice gift. So.
Excellent. Go ahead, Natalie.
Okay. Thank you, gentlemen. This is really fascinating research, and I appreciate hearing all these details, even though I don't completely follow all of it. But I am curious, and it is a little bit unfortunate that you did your research last summer, since we all experienced much lower ozone levels than the previous summer. And that was something that I had pondered. And one thing I didn't really catch is if you're taking into account like historical rain patterns and how the drought or rain might affect VOCs from plants, and because that was something that was different from, it was very dry this year, but the previous year it was wetter in the winter and we had much more plant growth. So I'm curious if you think that has an impact on this variability.
I got to go teach. Ave, I'll give you the hard question. Thank you.
Sure. So yes, this is an anomalous year as well in terms of meteorology for us. And so we usually have a lot of ozone exceedances. Yes, that's the idea, Natalie, that we wanted to understand the response of ozone on vegetation and the response of ozone on temperature and also with water and rain. So we're not yet there, and it just happens that we didn't. This is anomalous year. Hopefully, we'll have one again campaign next time. But there's this small, which is the LiDAR, that will still be available for us to look at in Phoenix. But yeah, that is something Taiwo has been looking at in terms of land cover. But for us modelers, we were really into the response of vegetation and on rain. We see again a really rapid response on the rain of the vegetation on rain, especially July, and unfortunately this time of the year, this year was kind of anomalous as well. But yeah, that is something we are working on.
Great, thank you.
I'm sorry to add something, Navi. I think it's also something, an area of research, just is something we've been trying to like also look into, like the impact of drought and also ozone formation as well in this area. Is something that would be insightful to look at. So
there is also a study currently just accepted looking at heat waves, Natalie. is ozone going to be enhanced during heat waves? And so there's a compounding factor that is important to consider.
Good.
Including
Next up, all right, Charles.
Yes, let me lower my hand. Taiwo, I want to congratulate you. That was very, very good presentation. And to all of you, my little company, Neochlorus, we fund research at University of Arizona, University of Illinois, and graduate students and postdocs are the backbone of what we learn in all fields of science. I'm an environmental engineer consultant, and when I moved here from Chicago, my eyes got pretty big at the proximity of these massive copper mines to our population centers. We have, of course, in Green Valley, we have the Freeport McMoran Sierrita mine, we have the huge Mission Mine Complex, et cetera. And these mines utilize, very, very large diesel-powered mining trucks. They have diesel generators. Have you looked at the impact of mining specifically as a point source for NOx and, VOC emissions that would contribute to ozone?
Thank you for that question. That is really insightful. What I would say is not yet, but at the same time, we need to put in mind that we don't have like surface measurements to look at speciated VOCs that might be emitted from copper mines, or have like surface measurement close to this copper mining location, which is one of the limitations I said earlier, because we need more surface measurement to look at maybe the impact of mining on maybe VOCs, look at the speciated VOC coming from copper mines and what kind of NOx as well. But sometimes if you use satellite data or remote sensing data, sometimes the coverage is kind of different. And for the NEI that we use, it's a 3-year estimate. Put in mind it's an estimate. It might not be an actual value. So it's kind of a good area to look into, but it will require like investment into having surface measurement in this kind of strategic locations to study the long-term impact of copper mine and its emissions on ozone in Tucson.
Yep. Just to add, Charles, so Tempo, which is the satellite that I showed earlier, is probably great at looking at NO2 over those hotspots. And so we're going to be looking at that. Very good point to make. What we were excited was that we wanted to compare and validate, maybe not validate is the right word, of NEI emissions inventory with the satellite, especially NO2, that we kind of is mature enough to actually see differences in the surface. We don't really have a problem. We have problems with formaldehyde and ozone, but NO2, yes. So that is something we want to look at. In the past, we just look at it from the aerosol side, the particulate side of the impact of mining. But yes, that's a great, very interesting insight. We will be looking at that. We see some hotspots in the NO2 data that we still don't understand. We thought it's fire, we thought it's prescribed burning, but sometimes it might actually be just a point large source. Thanks.
Great. Thanks for the question, Charles. We'll move on to agenda item 4 here, ozone monitoring update. We've got Kristen Randall Landrum, Air Program Manager with PDEQ, presenting air quality monitoring data from the 2025 ozone season and comparing with past years.
All right. Okay, well, thank you for having me. Just see how to control oh, there we go. Awesome. Thank you for the U of A folks and the GLOR researchers. They kind of covered a lot of ground, so I'll try to keep this short and not duplicate a lot of what they covered. And I don't know why my video is not working. So what we'll do is I'm going to walk you through where we are at with our ground level ozone in Pima County. what it is, why it matters for our health and planning, and what our monitors are seeing. I do have a few slides on the GLOR research, definitely not in any kind of detail, but how that sort of fits into the picture. There we go. Think of this as sort of a status check. Are we moving toward or away from potential non-attainment? We're going to start with that quick refresher first. So is basically how ground level ozone is formed. We've got our ozone precursors, nitrogen oxides and VOCs. There's a reaction with sunlight and high temperatures, and then we get that ozone there. I want to point out, and so we work with the public a lot. One of the things that I hear pretty often is, oh yeah, ozone. You know, we're driving into Phoenix and you see that dark cloud over Phoenix. That's not actually ozone. Ozone is colorless. So I like to remind folks that it's also different than the protective ozone layer that's high up in the stratosphere. And this is ground level ozone. It's what we are breathing in. So here we have the EPA standard for ozone. The current standard is 70 parts per billion. That's based on the fourth highest daily 8-hour average that's averaged over 3 years. So that's important because it means that one bad hour is not going to get you in trouble. It's not going to throw you in non-attainment. It's actually a pattern of these elevated days that matter. It means that an anomalous event won't matter for that. The 70 parts per billion standard is science-based. That is the standard that was set because it's believed to better protect kids, older adults, people with pre-existing conditions, and health. So I want to point out here that if we do end up eventually crossing into non-attainment, like our neighbors to the north, it doesn't just affect our air quality program, but it could trigger stricter requirements and can definitely reshape how we approach development in Pima County. This was covered in the last slide, last presentation, so I don't want to get into it too much. But I want to talk about the seasonal and diurnal ozone cycle in Pima County. So this top graph is just a representative graph from Children's Park. You can see that ozone sort of stays lower at night, starts to rise as the sun rises, sort of stays at that plateau, and then drops off pretty quickly as soon as the sun sets. The bottom graph here is this is our ozone season. Our ozone season tends to be April through September, usually when the days are longer and warmer. So why is ozone a concern? It is a health concern for people, especially people with pre-existing conditions. It affects the respiratory system and the cardiovascular system. So typically you'll see folks, elderly folks, people with asthma, COPD, lung diseases, or children especially affected by ground level ozone. We'll get into how we work with that in a second. So we're going to see this a little bit later. This is our color-coded air quality index for ozone. It's a public-facing table to help people conceptualize what the ozone levels are and how it might affect them. Here in Pima County, we work really closely with Natalie and with the Pima County Communications Department to issue ozone action days. So you can kind of think of this as an early warning system. We will forecast if ozone's expected to reach a level that could affect some of these sensitive groups, and then we'll issue an action day. This way, residents will be able to plan their days, maybe avoid strenuous activity outside, or even stay indoors if they need to. Over on the right hand of the slide, you can see that we issued 6 of these action days in 2023. We issued 14 of them in 2024, and then only 2 of them there. So this is our monitoring network. This is really similar to the map that was shown in the previous presentation. We do have 15 monitoring sites. 8 of them report on ozone. We do measure other criteria pollutants, but we're just going to talk about ozone for today. Ozone is a regional pollutant. It builds up throughout the day, as you've seen, and often peaks downwind of the major emission sources. So that's why we have these multiple monitors throughout the valley to see how the ozone is behaving from that urban core. So that's why you don't see like a single monitoring station, let's say like downtown. For regulatory purposes, a single problematic site, let's say like Saguaro National Park East, which is often where we see some of these higher ozone levels, can tend to drive the entire area's attainment status. So we want to have good coverage over the region. And here's what everybody wants to see today. These are ozone trends going all the way back to 2000. You can see that the ozone standard has been lowered 3 times. We are currently operating under the 2015 standard of that 70 parts per billion. You can kind of see that, you know, there's ups and downs. We're going to see this same shape in the data over and over again. We're going to look at a few other slides with data on it. But I want you to look over to the right-hand portion of the slide, see that 2015 standard. You can see where we have a gradual increase in the ozone concentration, and then peaking last year, and then we had a pretty calm year this year. Over here is just a different way to kind of see the data. So in the previous slide, I only had 3 representative monitoring stations. Here I'm trying to show all 8 of them. These are more of how many exceedances did we see per station. So you can see once again, we have that same sort of sawtooth pattern, and then starting in 2001, increasing to a peak in 2024, and then a low in 2025. And you can see which ones are our frequent flyer stations. I don't want to get into GLOR too much, but the question is, why are decreasing emissions not resulting in decreasing ozone? So this is a graph from our neighbors to the north from MAG, and you can see that although the emissions are decreasing, the ozone concentrations are generally increasing. So we had a wonderful presentation by the GLOR folks, so I'm not going to get into that. But I did want to bring up just that regulators are paying attention. I think that Karen Peters of ADEQ said it really well when she said that Arizona is not going to wait for someone else to solve it. The GLOR project is bringing together experts, and we're going to build a science-based framework for reducing ozone in our state. So we are definitely looking forward to those results and how we're going to use them to move forward. And with that, if anybody has any questions, please ask. I do have Mike Draper on here. He is our monitoring supervisor, and definitely if you've got very technical questions, we can answer anything you've got.
Great, thanks, Kristen. We can open up to questions. Ozone's obviously important for a region. We've just been under that 0.070 line for attainment. It helps that standards based on the 3-year average, and with the cyclical nature up and down, we've been able to average up just below that graph with Maricopa kind of pointing to removing exceptional events for wildfires could play an important role in our future. if we do see increases in that 3-year. So great visualization of what's been going on. Again, anybody have questions before we move on to the next agenda item? All right, well, I don't see any. Thanks so much, Kristen.
All right, thank you.
And everybody feel free to contact Kristen with any other questions. So we'll go on to agenda item 5, the next pollutant, which we do have a non-attainment area for RETO for, of course, particulate matter PM10. So we've got Allison Price and Jessica Wood from ADQ here to present on this topic. Go ahead.
Good morning. Thank you for having us, Dustin, and great presentation so far. This has been really informative. Okay, let's see. Just waiting to see. There we go. All right. Okay, so yes, I'm Allison Price. I am joined by my colleague Jessica Wood, and we work in the Air Quality Improvement and Planning section for Arizona's Department of Environmental Quality. And here today to give you a planning update on the RETO PM10 non-attainment area. So we will discuss a little bit of background and history on the area, cover ADQ's current planning efforts and progress that's been made. And then lastly, we'll open it up to some upcoming steps and if there's any questions. Okay, so I know I've got an educated crowd here, so I don't need to go into this in too much detail, but just a little bit of history in case there's some folks that maybe aren't as familiar with the Clean Air Act in the crowd. In 1987, the U.S. Environmental Protection Agency promulgated the 24-hour PM10 National Ambient Air Quality Standard, referred to as the NAAQS, as we've heard today, for particles that are 10 microns in diameter to be 150 micrograms per cubic meter. So what does that mean? It means that an air quality monitor cannot measure levels of PM10 greater than 150 micrograms per cubic meter more than once per year on average for a consecutive 3-year period. And then, of course, this image here, which I'm sure is very familiar to the crowd, just gives a visual for the size of PM10, about 1/5 of one width of single strand of human hair. So a little bit more on this history. And again, we got a visual of the RETO planning area on the screen here. But due to a lack of available ambient air monitoring data when EPA promulgated that standard, they created a tiered scale of group areas based on their probability for violating that standard, group 1, 2, and 3. And RETO was listed as a group 1 area, which essentially meant that there was a strong likelihood that it would be violating that 1987 NAAQS standard. And then as part of the 1990 Clean Air Act amendments, all group 1 areas were reclassified as moderate non-attainment areas for that standard. And we have kind of been in a planning period ever since. But in 2006, EPA, based on data from the 1992 to 1994 range, so again, that 3 consecutive year period, determined that RETO's non-attainment area had attained the 1987 NAAQS by the attainment date of December 31st, 1994. And the area has since violated the clean data determination, but EPA has not formally rescinded that clean data determination. So essentially, we are proactively working on the non-attainment area plan for RETO ever since that period. And ADQ aims to ultimately redesignate RETO as a maintenance area before a potential state implementation plan call under Clean Air Act Section 110K. So the major features that are in this RETO non-attainment area are, you can see some blue dots here on the screen. Those are some larger point sources in the area. And then right where it says RETO on this map is about the location of Arizona's state air monitor. And it is the only monitor that's located officially inside that non-attainment boundary. Some other prominent kind of features in this area are going to be, of course, the I-10 highway running through that eastern half, Saguaro National Park to that kind of southern border. and that it contains most of the town of Marana. And we'll flip to that next slide here. So yeah, before any legal obligations, we also just, for planning, we also want to point out that it's just important to be attaining that health quality standard for public health. So now what you're looking at here is a timeline of PM10 exceedances of those NACs from 2012 to 2024. And we do have kind of an up and down range happening. There's been a couple periods where it was attaining, but mostly not attaining. And we're currently trending down. So the 2022 to 2024 data, the most recent design value, is at a 3.4. So it is, again, still trending in the right direction, but violating the NACs still. And then just recall that it is that the metric is based on an estimated exceedances that can happen kind of once per year in a 3-year consecutive period. Okay, so when we are violating the NACs, it does trigger the need for the states to create a state implementation plan. So ADEQ's been at work on this, and some key components of a state implementation plan, or a SIP, is of course creating an emission inventory of all PM10 sources in the area, an evaluation of sources that contribute to the exceedance of the NACs, making permanent and enforceable controls that are relevant to those sources that we know to be contributing at higher levels, modeling to demonstrate the effectiveness of those controls, and then, of course, attaining by that attainment date that we're setting in the SIP. So plans are drafted here by ADEQ. If we have county level plans, they go to Pima County, since this area is within an air agency. And then it's not approved until EPA approves it, and then it becomes federally enforceable. So just, again, some of those kind of requirements. And then I will switch it over to Jessica to talk about the timeline for RETO and our SIP planning efforts.
Thanks, Allison. So I'm going to cover in the last few slides the timeline, kind of where we're at, give you some current status updates on the emission inventory and modeling, and then kind of next steps. So as you can see on the timeline, for the remainder of this year, the goals are to complete the base year emission inventory, to develop all of the modeling inputs, and actually complete the model, which then will allow us in the beginning of next year to commence the control measure identification, analysis, and rulemaking. And then into late spring, once those controls are identified and once they're identified, we'll begin the attainment modeling, which will take into account those potential controls and show or demonstrate, hopefully, that the area will then be attaining the NACs. And then into late summer and the remainder of 2026, it'll be drafting rule language for those controls, completing the remainder of the technical support documentation for the EI and modeling, and soliciting feedback on the rule language. And then moving into 2027, we'll kick off 2027 with the public process. Because there's the potential that this will include county level rules, there will be both the ADEQ public process for the SIP and any state level rules, and then the PDQ public process for any county level rules. We'll move into kind of, again, spring, early summer of 2027 with the wrapping up of those public processes, and completing the final steps of the rulemaking process with both the PDQ County Board of Supervisors and the Governor's Regulatory Review Council. All of this will hopefully culminate in the submission of the SIP in September of 2027 and the published rules. At that point, then it will be in EPA's hands to review and determine either approval or disapproval. So kind of a status update on the two current tasks we're working on. One of them is the emissions inventory, the base year inventory. We are very close to completing it. This emissions inventory will represent kind of the total PM10 emissions within the non-attainment area. I do want to point out that that these numbers will then be input into the model that we will be running, and the model will kind of determine influence at the monitor. So just because a sector is, on the larger side of the total emissions inventory does not necessarily, it's not a one-to-one correlation that will have the most impact at the monitor. So the few sectors that have asterisks next to them are still being or not finalized yet. Construction is the main one. We're still working through some of the road construction projects in Marana and following up on some data points with that. And then the 4 others that are marked with an asterisk is those are just not quality assured yet. So we'll have to finish that, which occurs in conjunction with the modeling inputs. So on the next slide, we are currently working on developing the modeling inputs for the air mod model that we plan to run. The top table identifies or highlights some of the sectors that we've already completed. I do want to highlight that ADQ has been working very closely with Cal Portland Rito Cement Plant, which is pretty much adjacent to the monitor in the non-attainment area. This is a very large and complex facility, and so we've been working quite closely with them over the past couple of months to develop those emissions sources from that facility and make sure that we are appropriately inputting them into the model. The bottom table highlights some of the sectors we are still actively working on. The majority of these are currently being converted or built into the inputs for the model. A couple are waiting on the completion of the emissions inventory numbers. And then, next steps is, as I mentioned with the timeline, is for the remainder of this year, completing the base inventory and the source apportionment modeling. We'll then begin a lot of our stakeholder outreach in the coming year or in the new year. Those dates are to be determined at this point because we don't want to hold those meetings until we have the results from the inventory and the modeling in order to have data-driven conversations at those meetings. And then additionally, in the new year, we will commence the control measurement identification and analysis. And that's it. Any questions?
Great. Thanks, Jessica. Thanks, Allison, for the updates on the Rito SIP. Any questions from the audience right now? Okay. Those next stakeholder meetings, it sounds like I saw on the timeline there's some next summer for the anticipated rulemaking. And are there ones prior to that for the emissions inventory?
Yes, I believe it's our intention to hold a few while we're in the control analysis piece and identifying those control measures to really, talk with, other agencies, stakeholders, community about which controls are feasible for this area. And then, yes, in the next summer, we'll have, or in the remainder of the year, once those controls are identified, there will be additional stakeholder meetings and what am I trying to say? Cooperation with especially the county in developing the rule language for those controls.
Right. Yeah, it'll be important for the county to participate, and then representatives from Marana in that area as well when it comes time. Well, thank you so much for the update. Appreciate it. We'll be waiting for the announcement for the stakeholder participation. And we can move on to next agenda item 6, EPA Climate Pollution Reduction Grant, the Comprehensive Climate Action Plan update from Natalie Shep. She's the Climate and Community Engagement Manager at PDQ, where she administers programs that support sustainable actions throughout Pima County, including the Regional Climate Plan Pima Can, as well as the Pima County Clean Air Program, and a new community air monitoring program at Pima County Schools. Natalie works with community partners, local jurisdictions, schools, and the University of Arizona to develop strategies and messages to encourage environmental sustainability. She received a BS in Environmental Sciences and a Master's in Public Health from the U of A. Take it away, Natalie.
Thanks, Dustin. All right, well, as Dustin said, I'm here to talk to you all about the almost completed comprehensive climate action plan that we have named Pima Can. So I'm going to go through that with you now. Do I have control? There we go. Okay. So this started in July of 2023 when we received a 4-year, $1 million climate pollution reduction, CPRG is the acronym, I'll be using that more, a grant from the Environmental Protection Agency to develop climate action plans to reduce greenhouse gas emissions from 7 sectors in Pima County. They call it the Tucson Metropolitan Statistical Area, which is the same boundaries as Pima County. I do also want to just say that this was funded by the Inflation Reduction Act, and this is a still in place. It's obligated funds. We do have another 1.5 years left that we expect to work on this, but this comprehensive climate action plan that I'm talking about today is the second deliverable, the largest deliverable of the grant. It also aligns with the 63 largest metropolitan areas in the United States, as well as all of the states that accepted the same funding. So it's not just something that's happening in Pima County, it's happening all over the country. Next slide. I can't move them. Oh, wait, yes, I can. Here we go. Not working. There we go. All right. So this is our timeline. As I said, we received that grant in July of 2023. Then we did some very broad public engagement, which I'm going to go through with you in the next slides, between September and January of 24. We then submitted the first deliverable of the grant in March of 24, which was the Priority Climate Action Plan, or the PCAP. And I'm going to explain the difference in these in an upcoming slide. That particular plan aligned with implementation grant dollars that were offered basically as a follow-up to that plan. And so we submitted a $250 million implementation grant to EPA. Unfortunately, we were not awarded. The only entity in the state that was awarded was Salt River Pima Indian Reservation with the tribal funding that they had, but the state and Maricopa also didn't receive that funding. We then spent some time looking for an environmental specialist, and Kaniz Fatima on the meeting here today is our wonderful specialist that we've been working with to do all the quantification work and the work that you'll see ahead here. And then in April through June of this last summer, we did sector-based stakeholder meetings where we focused on the different control measures of the different sectors and getting input specifically on those. And then between August and November, we've been working on an emissions reductions analysis of the selected measures. And then we've been working on drafting the CCAP, and it is currently with our graphic designers now. And we do intend to submit it in by December 1st, which is the deadline. Okay, so the goals of this based on the grant are to tackle damaging climate pollution while supporting the creation of good jobs and lowering energy costs, accelerating the work to address environmental injustice and empower community-driven solutions in overburdened neighborhoods, and deliver cleaner air by reducing harmful air pollution in places where people live, work, play, and go to school. These are the different required components of the plan. And so I'm going to go through these with you in the slides, but it's kind of just a summary. Before we can figure out how to reduce emissions, we really need to understand where the emissions are coming from. So we're using PAG's 2021 greenhouse gas emissions inventory that Dustin developed as our baseline year. So 2021 is our baseline. Then we are required to develop these emissions projections into the future, business as usual, to kind of demonstrate if we do nothing, what will that look like? Then we have to actually determine what our targets are going to be. How much do we want to reduce them in a short term and long term? Then we have to identify the measures, and we have to have emissions reductions measures for 7 different sectors. And then we have to actually do projections for those measures. So we're going to look at business as usual, and then we're going to look at the projections with the measures and see the difference there. Stakeholder engagement was also required, as well as a co-pollutant benefits analysis. So we're going to look at the greenhouse gas emissions reductions, but there are many side benefits from reducing greenhouse gases, and that is that we are also reducing those co-pollutants, so the air pollution that we're talking about. So we have to do an analysis for that, and also look at what some of the other public health or economic benefits or disbenefits may be. Now, I have here the low-income and disadvantaged communities benefits analysis, and I have a line drawn through it. And that's because when we first received the grant, it was under the Biden administration, and they did require this LIDAC benefits analysis. So if you look in the PCAP, which is online at pima.gov/climate plan, you can see that we did a very detailed LIDAC analysis using a tool that EPA developed called CEJST, which is the Climate and Economic Justice Screening Tool. So we did do a very full-scale LIDAC benefits analysis. When the administration changed, they pulled that back. They took away the tool, and then they told us that that was not required. So you will not be seeing a LIDAC benefits analysis in the CCAP because we simply weren't able to do it because the tool is gone. However, I do think that the benefits analysis we did in the PCAP is still very sufficient, and we are very focused on ensuring that the benefits that we see from the emissions reductions measures are strategically targeted to those underserved communities that have historically had to bear a greater burden for climate change. So we haven't really changed our tune on that. We just simply can't do that same analysis in the CCAP. Then we also look at based on the measures, who has the authority to implement them, and where is that jurisdiction? We have to outline that. And we have to be looking at intersection with other funding and how that other funding can help facilitate the implementation of some of this work. And then the last piece is a workforce planning analysis that we have to do to show what kind of workforce shortages there are in order to be able to achieve some of the measures that we outline. So this is the stuff I'm going to get into in more detail next in the coming slides. So when we first received this grant, we reached out to all of the jurisdictional partners to ensure, to basically build a coalition of willing partners who wanted to participate in this process. And when we did that, we heard back from the city of Tucson, the town of Oro Valley, this Tohono O'odham Nation, and the city of South Tucson. And they have all been a part of this coalition effort that we have been doing over the last year and a half. So the others opted not participate. And I will say that PAG is also a partner in this as well. They were huge in helping us develop having the emissions inventory for the base year, and also working with us on doing some of the analysis for the measures. So the community engagement that we did was in that first part for the PCAP was a community survey. We got over 2,000 responses. We also did a business survey. And then we also worked with, we provided funding to 5 different community-based, or is actually 4 community-based organizations in 1 jurisdiction to help us conduct outreach in those LIDAC communities, those hard-to-reach communities. So we provided funding to the nonprofits like Ishkashita to help us reach refugees. Direct Center helped us reach disabled and elderly folks. Youth for Blue Skies helped us reach youth, etc. So we were able to kind of get that additional information directly by working with those organizations. And then, as I said, we did host those 11 sector-based stakeholder meetings last summer to talk specifically about the measures that we should be putting into the CCAP. So just a quick kind of summary of the public survey results. One thing I will say is that we did hear loud and clear that people want their government to be working on these issues and they want them to act. So that was very straightforward in the feedback that we got from the public. And then generally speaking, when we looked at some of the questions about what are they most concerned about, water accessibility and security definitely rose to the top, and excessive heat was also at the top. So those are the two big biggies that people are very much worried about, or they're already dealing with that, like with excessive heat. Impacts to tree health and green spaces and biodiversity, hardships on future generations, increased wildfire. Those are the other main things that people said they were worried about. As far as things that are already impacting their life, I think we all know that excessive heat is definitely impacting all of us. That then, of course, leads to higher energy costs, drought, poor air quality, and impacts of health. And you can see there at the bottom, pima.gov/climate plan. You can see all the results of the survey in detail. You can also see the reports from our community-based organizations. A lot of information on that website if you want to drill down a little more deeply on any of that. So what is the difference between the PCAP and the CCAP? The PCAP, which was the first deliverable, was a list of shovel-ready priority projects for emissions reductions. Those projects were then included in that grant application that I talked about, which was not awarded. But it did allow for us to really identify what are the priorities. If we get some funding, what would we want to do first? What would give us the biggest bang for the buck? So those projects that we had identified, basically in summary, were the Los Reales landfill methane capture project, where they wanted to capture the methane instead of just flaring it in order to try to turn it into natural gas to fuel their fleet, their natural gas vehicles, things like buses and refuse vehicles. That was the largest piece of that grant application that we applied for. The other projects were Pima County wastewater and Tucson water energy efficiency projects for both of our governments, wastewater for Pima County and drinking water for Tucson water. Those are the largest energy users of our government. So really focusing on trying to create some efficiencies with the energy that's used for those processes, things like water pumps or wastewater treatment, was a priority for us. In addition to that, we were looking at energy efficiency and solar installations for local government facilities, and that did include Oro Valley and South Tucson, as well as government vehicle fleet transitions to electric vehicles, and as well as a public EV car share program, and then expanding public composting beyond what is already happening with the city and organizations like Compost Cats. So when we get into the CCAP, you're not going to see those projects because they're in the PCAP, and it's not really a list of specific projects. It's more of a high-level list of greenhouse gas emissions reductions measures that are recommended for implementation in order to reach our target of 60% reductions by 2030 and net zero by 2050. So I'm going to get into some of that in a little more detail now. So the emissions inventory is a really key component here because, like I said, we have to understand where the emissions are coming from in order for us to most appropriately select measures to reduce those emissions. So we have the 2021 base year emissions inventory that was developed by PAG and used as the base year for both the PCAP and the CCAP. And then we have the short and long-term business as usual scenarios that we modeled, and then the 2030 and 2050 out years with the proposed greenhouse gas emissions reductions measures. So we can see the difference between that business as usual scenario and the one with the measures. These are the 7 sectors that EPA has defined within the grant and that we are required to find measures for. At least one measure has to be for all of these sectors. So we have the electric utility sector, commercial residential buildings, transportation, waste and materials management, industry, working lands, and agriculture. And I will say here that pretty much all of these 1 through 5 and then 7 are emission sources, putting out those greenhouse gases into the atmosphere. Working lands is kind of the opposite of that, in that it's calculating the uptake of greenhouse gases or carbon dioxide from plants and soil. That's tough to actually quantify, but it is important because when we talk about net zero, we're not just talking about stopping all emissions, we're talking about basically kind of leveling it. So anything that's uptake that basically is emitted really needs to be taken up by plants or the soils, or artificially through carbon sequestration, if that were available, those types of things. So those are the sectors. And when we look at the emissions inventory, you are going to see that there's going to be a little bit of variability in the sectors and kind of how we display the data. And that's because of the model that we use. They don't completely line up the sectors that EPA has with how those things are being quantified. So you're going to see some variability in what I'm showing you here. This graph shows you the emissions from the different sectors for the 2021 base year. And you can see here that transportation is the largest source of greenhouse gas emissions in Pima County, followed closely by stationary energy. Stationary energy is including really, the energy that's used to generate electricity for homes and buildings, as well as natural gas that might be burned for heating or using boilers at buildings. All of those are wrapped up within stationary energy. Transportation includes our on-road mobile sources, which is the majority of it, but it's also the non-road sources such as mining equipment, construction equipment, things along those lines. When we look at industrial processes and product use, this basically is the most of this is Cal Portland. What we had looked at with the Rito non-attainment area, Cal Portland is a very large emitter of greenhouse gases. Cement production is very energy intensive, and it generates a lot of CO2. So the majority of that is from Cal Portland there. And then much smaller amounts coming from waste. And the waste is really, really coming from things like methane from the landfill. So it's different. It's not fossil fuel burning necessarily, although they are burning the methane off. And then you can hardly see it here with the agriculture, forestry, and other land use is kind of wrapped up together. That one's actually going down. So that one actually is the uptake. And so we're seeing that's like the forests and the lands that are taking in that CO2 there. So this is where we're starting from now, or a few years ago. Probably it hasn't changed all that much. This is what our model, which we've used. We are using a model called ClearPath, which was developed by ICLEI, and ICLEI is the international organization that basically helps local governments do this work around the world. So we're using their model, and you can see here, I guess it goes from 2021 to 2050, and there's a steady increase in those emissions if we do nothing, as you might suspect. Okay, so let's get a little bit into the targets that we are being asked to set. So we are setting science-based targets, and what that means is that they align with the latest climate science. We actually worked with ICLEI to come up with these targets, and they represent the community's fair share of the ambition necessary to meet the Paris Climate Accords that were developed about 10 years ago. And that's a worldwide effort to try to keep our average temperatures below 1.5 degrees Celsius. Unfortunately, we've recently surpassed that, but this still aligns. And even though the United States has opted out of Paris, Pima County is still very dedicated to trying to keep with it as far as our goals are concerned. So the federal government's decision to do that is really not relevant to our decision to do it. And so back in 2017, the Pima County Board of Supervisors passed a resolution affirming its commitment to the Paris Climate Agreement. And then again in 2022, they adopted another resolution which aligned with the national recommendations to a set economy-wide target of reducing greenhouse gas emissions 50 to 52% below 2005 levels by 2030. This was for our Pima County operations only, not for the regional emissions. And we did meet that goal in 2024. And then this year, on May 6, 2025, the board again adopted a new target to reduce county operation greenhouse gas emissions by 60% below 2021 levels by 2030. And that aligns with the target that we're putting into this regional plan, the CCAP. So we do have that target at 60% below 2021 levels by 2030. That's a very lofty goal. And trying to reach that net zero goal along with hopefully the rest of the world by 2050. So I've basically summarized here for you what we just completed. This has only been recently finished, and you don't really have to worry too much about the numbers, but I want to put the numbers in there to basically show you the kind of the scale differences with the different sectors and what we're looking at. So with the electric utility sector, we have one measure, and that is to expand utility scale renewable energy and battery storage. When we mean utility scale, we mean those very large solar fields that you might see when you're driving along the freeway. TEP already has very large scale utility scale renewable energy, and they've just completed a very large battery storage project. And so that is going to have by far the biggest bang for the buck from this sector. But I will say that the rooftop solar, theoretically could be in that sector since they do utilize any additional energy that's created from rooftop solar, but that particular measure is in the building since the energy is being generated directly at those buildings. So you can see here, if you look at 2030, we've got pretty significant drop. But if you look out to 2050 with what we need to do, then we have a substantial drop in emissions simply from this sector with almost 60 million CO2 equivalent basically reduced. So this is, if you look here along 2050, that's going to be the largest reduction that we have from what we have analyzed. Then we get into the residential and commercial building sector, and we want to increase the deployment of distributed renewables, which in our case mostly means rooftop solar, as well as on-site battery storage, which has a significant drop, but it's quite a bit less than utility scale solar. So that just kind of shows you that really it's great that we are moving forward with rooftop solar. We need to definitely do that. But when we look out to 2050, it's going to take the utility scale solar to get to where we need to go. Improving home weatherization was the other one, and that's going to be things like replacing windows, weatherizing homes with insulation, making homes more energy efficient, basically. And then we also have installing efficient heating and cooling equipment and home appliances. And the big one here that we're looking at is things like heat pumps. So really trying to transition to heat pumps as the most energy efficient appliances. And trying to get away at when we replace, air conditioners or heaters, we want to look to try to achieve the best efficiency possible, and that is going to be through heat pumps or highly efficient air conditioning units. Then when we get into the transportation sector, we're going to have by far the biggest drop from replacing internal combustion vehicles with electric vehicles. You can see the difference here. And so we have all those vehicles on the road, and eventually we will need to try to provide encouragement and do more public charging so that we can really encourage folks that when, maybe those internal combustion engines need to be replaced, that they are being replaced with electric vehicles or hybrid vehicles. And then the second measure is expanding and improving public transit to promote more use. But you can see here that is significant out to 2050 when we estimate those emissions reductions. Although significant, you can just see that there's huge difference between the EV measure and the bus measure. And then the third measure is improving urban planning to increase active transportation. So the model will take into account a lot of different variables in the back end of it to determine kind of the viability or how realistic it is that maybe folks might be taking up active transportation if we do more proper urban planning. And so that is already taking place right now with the City of Tucson and their Move Tucson plan, as well as some of the efforts that PAG is taking. The other sectors here, we've got waste and materials management. So we're looking at increasing composting of organic material, which has the most significant reductions. The methane that's coming from landfills is mostly coming from the from organic matter. So reducing organic matter from the landfill is going to have more of a profound impact than, let's say, reducing plastic or things like that. Although we do have increasing recycling of solid waste, which would give us some benefit. Another measure that we did want to include, but we don't have a proper way to quantify it, so we don't have any numbers with it, is just simply reducing food and organic waste as well as reducing solid waste. So we want to try to reduce that before we move to composting and recycling as kind of the first step. So we felt like it was important to include that as a measure. That's the same that goes for when we get into industry, improving industrial energy efficiency. That was included in the building analysis, so I don't have separate numbers for that. But we're talking about, industrial processes and energy that they use, and there's a lot of different ways that those industrial processes can be improved with energy efficiency measures. So that's what that is referring to. And then when those industrial processes use fuels, we want to try and encourage them to move towards electrification if possible, or using low carbon fuels. And we get those numbers there with that. Then we get into working lands. We do feel like expanding green stormwater infrastructure is probably the most critical piece here. It's something we're doing a lot in this region, many different jurisdictions working on it, a lot of work around it. It can have multiple benefits beyond just taking up carbon dioxide, but I don't have a number there. It's just included with the green spaces. So when we look at expanding urban green spaces, that's going to be things like just, tree planting, community gardens, anything we can do to plant more plants and create more green space. That's the reductions that we get there. And then with agriculture, we're looking at the measures being reducing fossil fuel use in that equipment. So those are the numbers there, and those are kind of part of that transportation sector as well. And then implementing crop rotations to improve soil health. Things like regenerative farming practices can uptake the carbon dioxide from the atmosphere into the soil. And we don't have any numbers there because there's just not a great way to quantify that either. So those are the measures that we have included in our CCAP. Now we look at, this is directly from the model, the ClearPath model that we used. And you can see here when we include all of those measures. So the red line is basically if we do nothing. The green dotted line is if we meet our net zero goal. And the wedges in between are what we're looking at with the reductions in the different sectors. So you can see here that we are not able to model net zero. We are able to get close and do significant reductions with these measures, but we still have emissions at 2050, even though we would rather not. So it's a lot of work to do, but this is basically how it plays out with these measures based on the modeling that we did. And then you don't have to digest these numbers in detail either, but I did just want to demonstrate the co-pollutant benefit analysis that we did. The EPA offers a tool called AVERT to kind of look at different energy related measures and estimate the emissions reductions from those. So they were able to do that for us for the electric utility sector, which did include the kind of the buildings within that as well as the electric transportation. And you can see here that when we reduce greenhouse gas emissions, we do significantly reduce our criteria pollutant emissions as well. So in the ballpark of 10 to 12% reductions in the different pollutants. And so that's going to have significant health benefits if we can do that. So we definitely want to address climate change, but simultaneously we want to make sure that public health is protected from these emissions. And so we have some significant additional benefits that we get when if we were to implement all of these measures. And then when we did the workforce planning analysis, we kind of lucked out because at the same time that we were trying to do this, the Arizona Office of Economic Opportunity received a grant to actually do a green workforce analysis. And they are the experts in workforce. Unfortunately, I'm not a workforce expert, but they were able to provide us with a lot of data that helped us kind of analyze where our shortfalls might be. And that workforce analysis will be included in detail in the CCAP. And as according to that analysis, the largest workforce gaps we're going to have, because of course, if we want to do all of these measures, it's going to take that human power to get it done. Things like installing solar panels or EV charging stations, or even agriculture and industry. We need expertise in all of these things in order to actually accomplish it. And so the gaps are really, unfortunately, in things like electrician helpers and electrical assemblers, home appliance repairers, regional planners, environmental engineers, landscape workers, tree trimmers, nursery workers, and ag equipment operators all kind of stood out within the jobs that we looked at as potentially having shortages. So when we work with our community workforce development department, we want to make sure that we're kind of building in these workforce development opportunities for these particular jobs to ensure that we have the human power we need in order to accomplish what we want to do. And this CCAP will be submitted to EPA by December 1st, 2025. And that is coming right up. So we're hoping to get it submitted to them by the day before Thanksgiving is my goal. So that is all I have for you today, and I'd be happy to answer any questions.
Great. Thanks so much, Natalie, and congratulations to you and Fatima on getting this done and submitted and answering the how and why of where to reduce those emissions. And it's going to be a great resource for the region. We got Kristen with a question.
Hi, no, I just had a comment. I know Natalie and I work in the same department, but I don't often get a chance to learn about what you're doing. And this is just such a heavy lift. And I think it's so positive. And thank you so much for presenting on it. It's amazing.
Well, thank you, Kristen. Appreciate that.
Thanks. Anybody else with questions? All right. Thanks again, Natalie. Appreciate it. Thanks to all our speakers today presenting to the AQS members and EPAC on ozone and PM10 and climate planning. If anyone had any additional questions, you can send those to me. I can pass them on to the speakers. I'll move on to the last item, adjournment. And we'll see those of you EPAC members, hopefully our next meeting's planned for December 11th. Thanks again, everybody. Have a great day.